Imagine standing beneath the scorching African sun. No sunscreen, no sunglasses, no hat, no air conditioning, no shade except the occasional tree. The temperature climbs past 100 degrees Fahrenheit, and the sunlight is relentless, hour after hour, day after day. Now imagine living like that, not for a vacation, but for your entire life. It is easy to assume ancient humans must have been immune to the sun. After all, they survived outdoors for hundreds of thousands of years. Surely they never worried about sunburn. Surprisingly, that is not entirely true. Some ancient humans probably never burned at all. Others almost certainly did. And the reason reveals one of the most fascinating stories in human evolution, written not in books, but in our skin. Because every shade of human skin alive today, from the darkest brown to the palest ivory, is the result of an evolutionary balancing act unfolding for nearly 2 million years. To understand whether ancient humans got sunburned, we first have to answer a bigger question. Why does human skin exist in so many different colors? The making of a shield. If you traveled back 2 million years to East Africa, you would not recognize the earliest members of our human family. They looked different, walked differently, lived differently. But one thing would surprise many people. They probably were not very hairy. Scientists believe our ancestors gradually lost most of their body hair as they evolved into long-distance endurance runners. Instead of panting like dogs or relying on thick fur, early humans cooled themselves by producing sweat across millions of tiny glands. As sweat evaporated, it carried heat away, allowing humans to remain active during the hottest parts of the day when predators rested. It was one of the greatest survival advantages our species ever developed. But losing body hair created an entirely new problem. Without fur, skin was directly exposed to ultraviolet radiation. UV light is invisible. You cannot see, smell, or feel it immediately, but it carries enormous energy. When too much reaches your skin, it damages the DNA inside your cells. Your immune system reacts, blood vessels expand, inflammation begins. The result is sunburn. So would any ancient human whose skin lacked sufficient protection have experienced it? Nature's solution was melanin. Melanin is the pigment responsible for skin color, but its real purpose is protection. Think of it as millions of microscopic umbrellas packed inside your skin, absorbing UV energy before it can reach and damage your DNA. The darker the skin, the greater this natural protection. In the intense equatorial sunlight where humanity evolved, this was not simply helpful, it was essential. For hundreds of thousands of years, nearly every human ancestor living in Africa likely possessed deeply pigmented skin. Genetic evidence strongly supports this. The reason was not beauty, it was survival. Tropical sunlight threatens one nutrient above all others: folate, also known as vitamin B9. Folate is critical for cell division, fetal development, and reproduction. Too much UV exposure destroys folate circulating near the skin. Without it, pregnancies become riskier, birth defects increase, and fertility declines. In evolutionary terms, that is a catastrophe. Dark skin blocked UV radiation before it entered the body, preserving folate and giving individuals a far greater chance of producing healthy offspring. Then vitamin D created the opposite challenge. Unlike folate, vitamin D requires sunlight. Your skin manufactures it after being exposed to ultraviolet B rays. Too much melanin blocks harmful radiation, but also some of the sunlight needed to produce vitamin D. Near the equator, this was not a problem. Sunlight was abundant year-round. But everything changed when humans began leaving Africa. Roughly 70,000 years ago, groups spread into the Middle East, Europe, and Central Asia. The farther from the equator, the weaker the sunlight. Long winters, cloudy skies, short daylight hours. The same dark skin that had protected generations in Africa became a liability. People in northern climates struggled to produce enough vitamin D, which weakens bones and reduces immune function. Over thousands of years, natural selection favored lighter skin, allowing more of the scarce sunlight through. This was not evolution choosing one skin color over another. It was evolution adapting to different environments. Skin color became one of humanity's greatest examples of biological flexibility. So did ancient humans get sunburned? The answer depends on where they lived. Early Africans with deeply pigmented skin rarely experienced severe burns. Humans who migrated carried different levels of protection. Nature never created a perfect solution, only trade-offs. Behavior, clothing, and the Neanderthal question. Skin color was not the only defense ancient humans had against the sun. Behavior itself became a survival tool. Archaeological evidence and studies of modern hunter-gatherer societies suggest that early humans organized their days around the sun. The hottest hours were reserved for resting in shade. Work resumed in cooler mornings and evenings. Humans combined this instinct with intelligence, building temporary shelters, seeking caves, resting beneath trees, and eventually wearing clothing that shielded skin from direct sunlight. Clothing tells a particularly interesting story. Scientists estimate humans began wearing garments between 100,000 and 170,000 years ago. Animal skins rarely survive archaeologically, so researchers turned to something unexpected: human lice. Body lice can only survive in clothing. Genetic studies show they split from head lice at roughly the same time humans began regularly wearing garments, giving scientists a biological timestamp for when clothing became consistent. Those early clothes were not fashion, they were survival equipment. Animal hides protected against cold, scratches, insect bites, and sunlight. Even lightweight coverings dramatically reduce UV exposure. What about Neanderthals? Did they burn more easily than modern humans? Possibly. Genetic studies suggest some Neanderthal populations carried variants associated with lighter skin and reddish hair. Neanderthals spent hundreds of thousands of years in Europe and Western Asia, where sunlight is weaker than in equatorial Africa. Lighter skin helped them produce enough vitamin D through long winters. But transported to tropical Africa, those same individuals would likely have burned far more severely than populations already living there. Environment shaped biology. Biology reflects the environment. One common misconception is that only light-skinned people experience sun damage. In reality, everyone can. Darker skin makes sunburn less common, but it does not create immunity. Ultraviolet radiation still damages cells. It simply takes longer. Dermatologists emphasize that people of every skin tone face increased risk from prolonged exposure, premature aging, eye damage, and certain skin cancers. Ancient humans were no different. Their risk depended on genetics, environment, behavior, and the hours they spent under the sun. Cancer, reversal, and what the sun means now. Did ancient humans develop skin cancer? Almost certainly yes. Cancer is not a modern disease. Scientists have found evidence of tumors in dinosaur fossils more than 70 million years old, and ancient human skeletons show signs of various cancers. Skin cancer leaves few traces on bone, making it hard to confirm archaeologically, but biologically there is no reason to believe it did not occur. Ultraviolet radiation damaged DNA then exactly as it does now. The key difference was life expectancy. Many prehistoric humans died from infections, injuries, or accidents long before cancers had decades to develop. Those who survived into old age very likely experienced diseases remarkably similar to our own. Our relationship with the sun has also reversed. For most of human history, the greatest danger was too much sunlight. Today, millions spend nearly every waking hour indoors. Office buildings, homes, vehicles, and screens have replaced open landscapes. Many people now receive too little natural sunlight, contributing to widespread vitamin D deficiency. Our ancestors searched for shade. Many of us now search for sunshine. The biology has not changed, only the environment has. What the answer actually reveals. So did ancient humans ever get sunburned? Yes, some certainly did, but many did not, because evolution had already equipped them with one of nature's most effective forms of protection. Over hundreds of thousands of years, human skin became a living record of the environments our ancestors called home. Dark skin evolved beneath relentless equatorial sunlight, protecting folate and shielding DNA. Lighter skin evolved farther from the equator, allowing scarce sunlight to produce enough vitamin D for survival. Neither was better, neither was worse. Each was a precise biological solution to a different environmental challenge. Every freckle, every shade, every variation in pigmentation carries the story of countless generations adapting to a world that never stopped changing. The next time you feel the sun on your face, you are experiencing the same star that shaped every human before you. Its light influenced where we lived, how we survived, and the color of our skin. The story of humanity is not written only in history books, it is written on us. If this changed how you think about something as ordinary as sunlight, share it. Leave your thoughts in the comments below. Like the video and subscribe for more science most people will never come across.